So in the unit number 1, we have seen the basics of your statics and some of the problems in when a body, when the number of forces are applied to a body, and we have just covered how force, even if it is in an inclined position, is been converted into two components. That means a single force converted into two components of either in x and y direction, or I can say horizontal and vertical directions, in order to get the resultant force. And next we have seen about vector and scalar representations, and I have made you understand that the purpose of scalar and vector is also to find out the resultant only, but using the mathematical calculations of either addition, subtraction, or your multiplication, cross product, dot product, all this. So that's about unit number 1, and there are a number of problems solved in the books. So the basics are, I hope it is done clearly so that you can understand better, but you need to practice a more number of problems and clarify your doubts if required. But before that, any force considered in any problem, basically, as I previously explained, from the 0 degree to from first quadrant, second quadrant, third and fourth quadrant, you will have to first decide whether the force is coming towards the body or it is going away from the body. That, if you are very strong in that basic, the remaining things are only the addition or subtraction based on horizontal, or it is right hand side, left hand side, and sign conventions. So please keep that in mind. And now I am moving on to unit number 2, where it is known as the equilibrium of rigid bodies. Equilibrium of rigid bodies. I have already explained what is the rigid body means. So it is a body to which, where the force which is applicable may be of different in nature. It may be concurrent, non-concurrent, collinear, etc., etc. But due to that force, the difference of the application, due to the application, the moment or the change of or displacement is considered to be very, very small, negligible. And for this body to keep in equilibrium condition, in an ideal condition, it's very difficult to keep a body in equilibrium because the number of forces applied to the body to be balanced properly. That's what we are trying to make it in body equilibrium properly. And the balancing or making equilibrium differs in two ways. One, when the body is in static equilibrium. Static means the body is not moving. So there you need to keep a body in equilibrium condition. Say for example, a table is kept or a chair is kept. We are not moving the chair or the table, but still the body has to be in a stable condition. That is one setup. It's called static equilibrium. In the same thing, when a moving body, suppose example of a car or a moving body, a bike, whatever it is. So there, when the number of parts inside the body is also in action, either it is moving or the whole body setup is moving. So every particle inside that body is also considered, and we are studying about the particle, the movement of the particle, whether it is static or if it is moving, it is in dynamic equilibrium. For this, you need to just differentiate between the forces which are directly applied and forces which are indirectly applied. In the sense, I will just consider a body that, for example, I will take a fan. No, it's a household fan. We know what is the fan is. Normally, what is the condition? The fan, I can say a ceiling fan, okay? The ceiling fan, or the ceiling fan, it will be just hanged on from the top of the ceiling. What is the condition? We have a nut and bolt there, which is fixed to the top of the roof, and a rod is fixed in the center, and to the end of the rod you have the hub, in the sense the motor, your capacitor, whatever it is, and the side we have the fins or the, I can say, leaves, 3 or 4 leaves, whatever it is. So actually, before you switch on a fan, the first thing is, what we are doing is, when you bring a fan, for fitting it, we are just holding it, and one person will hold it from the bottom and other person will just tight the bolt and nut, and which is the rod is fixed. That rod, I can say that area will take up the total force, will be holding, for which we have an kind of arrangement made in the roof which will keep the body in stable condition. That means if the fan is probably in, if you switch on the power is given, it will rotate, but still that in the first condition, static condition, also the any number of hours, if the fan is it is not on or off, the body has to first be in a stable condition. It should not either vibrate or imbalance should not be there. Second point, when you switch on the fan, it has to rotate. When rotating, if every condition is proper only, you will not have any other unwanted noise or vibrations while it is rotating. What I am trying to explain is, so to keep that particular fan, a body in equilibrium condition, equilibrium means it should not go out of the required, say the designed work, what we require. It needs just to give air by rotating. That's what the work. Now I will just draw a fan. Suppose you consider this is a fan, it has been considered. Right? This is the body. Okay. So this body, what happens to this? I'll just say this from the top it is connected here, and your fins, I can say in different, or the leaves are there. From the top, the bolt it is just holding. So there is a pull. That means I can say from this, if you consider this as a body, fan is a body, right? There is a tension from the particular point which will keep on holding it in the balanced condition, right? And due to the self weight of the fan has got some weight, some kgs. Due to that, the body will keep on trying to, I say it's pushing down. So this can be represented with a line diagram. Now I am talking about a fan which is in the static condition, it is not running. Okay. So whatever it is just, I'll just write a line diagram. I'll just indicate with this, with one force which is a pull, or I can say it's a tension. Tension means you can say that a particular rod which is connected between your actual fan, that hub area as well as the top bolt. So that will just keep on holding it, and it's pulling, holding it in the balanced position. And due to the fan weight, you will have its weight of the fan. It will be hanging down. So in general, these two conditions are, these two forces I can say. This weight is also a force in terms of Newton, we can convert it, kg to Newton, by multiplying your 9.81 that value. And this pull is another force which is in the opposite direction. So, in generally speaking, to keep a body in equilibrium condition, you will be normally needing at least two forces which could be balanced. These two forces which keep the body in equilibrium condition. Okay. So, this principle, there are a number of names, 2-force principle, 3-force principle, etc. based on the number of forces applied to the body. But from a normal body, when you indicate the applied forces for the body by omitting the other forces in that particular area. Say for example, I am separating this fan. In a room you will have normal atmospheric conditions, say the air inside the room, some value of air pressure, whatever it is. So even that air pressure is also by natural, the air condition of the room, the fan, the leaves can rotate. So we can normally think about the general idea. When you switch off the fan also, even due to the atmospheric conditions, the leaves will sometimes rotate. Right? So that forces are not taken into consideration. When that forces are not taken into consideration, and we are worried about only the applied force for that particular body, that will become a free body. Free body. The meaning is, when you omit the surrounding forces which is applied to a body and consider the forces which are actually applied to the body, that body is called a free body, and a diagram which indicates only the applied forces to that body is known as free body diagram, right? It's free body. So the free body means we are considering only the applied forces, only the force applied to the body, applied to the body. Okay, so this particular body, that the diagram which shows that free body, forces applied to the body, is called a free body diagram. Free body diagram. This free body diagram is a very important diagram wherein if any body is given, the number of forces applied to that body can be differentiated or be written only in terms of just an arrow mark which denotes the force, whether the force is towards the body or away from the body or inclined to body, whatever it is, the condition is. Like that, n number of free bodies we can write, which will make the problem easier, okay, from the complex to the easier condition, so that you can easily solve it by considering the horizontal forces, the vertical forces, then going for resultant, then finding out the angle. That's what we did in unit number 1. So the concept is same, but we have to identify which are all the forces actually applied to the body, right? So in this free body or free body diagram, we can see there are a number of examples, okay, is given in the book, as well as for which you have to understand actually how those forces are being indicated. It is very important to understand how those forces are indicated. It will be just given in illustration. In the sense, I just take, this is the body shape. Body is given, and this is forces. I will be considering body number 1. How does it look like? I will just take one container. Okay. In this, I will just consider there is a ball. This is a ball, or let's consider to be a body or particle, whatever it is. It is just placed in a container. You can see clearly that, you can imagine this ball is touching, or it is it is having a support in this vertical wall, and it is resting on the ground also, which means you just consider the corner of a room in a house. We are just placing a ball, a football or a volleyball, whatever it is. No, it's an example. Just place it there. So it will have either it can touch in the 3 corners also. That means one is in the ground, either vertical as also horizontal also. Otherwise, consider only it is touching it has been placed in the horizontal ground, but it is been supported by the vertical wall. Now for this one, I have to write forces by FBD. FBD means free body diagram. Free body diagram. Okay. How can I write the free body diagrams? The forces applied to the body alone is a question, right? And it will have some weight, is it not? The body will have some either mass or weight programs. Now what I will do, I will just draw a plus, a symbol, okay, which can indicate the number of degrees, the 0 to 90 or 180 and 270, etc. And this one, I will just first consider, always we have to consider the weight of the self weight of the body, basically. So this, due to the self weight of the body, I can indicate a sketch like this. This becomes weight of the body. Okay. I take it as W. This is due to weight of the body. And there is a point which is the body is resting in the ground. Since the ball is resting on the ground, if the ground is not able to support it, that means it has to give an opposite reaction, is it not? It has to give an opposite reaction. If the reaction is not given, what will happen? Consider that you are just keeping it in an area where it could not support from the bottom. The ball will go inside. Is it not? So that opposite reaction is to be taken into consideration. That I will take it as another force. It is an upward force. or reaction. It's a support only, it's just coming a reaction because from this area. Okay, this force I can just take it as, say suppose this is point B and this is point A. Okay, I'll take this is force B. Force B is acting from the bottom to the top. That's the consideration, directly vertical. Okay, this is the weight, due to the weight of the body, self weight of the body, it is hanging down. So we can take FW or force due to weight. This force is due to at point B, it is acting upwards. What about this one? This ball, it can either roll around, it can come like this, go to the other end also, or it will be in the center also. But present position I have shown it, it is being supported in the left hand side. So this left hand side also I should show the force which is acting away. I mean from the here from this end there is a force which is acting towards this ball so that the ball is resting. Is it not? The ball is touching this and this is should be a support for this. That's why it's weight. The resting. This one force. So I can say this force from point A. This force A, due to self weight it is FW, and reaction from this bottom it is FB. It is, you can take reaction for this also, no problem. Even it can be taken as RA. In the sense, there is an action, that means action in the sense it is leaning towards the wall, vertical wall, and this will give an opposite direction. So this diagram which we are drawing to consider. So this sketch, the number of forces acting on this body is being taken in terms of this line diagram, and this diagram where we consider only the number of forces directly acting on the body is known as free body diagram. This is what the example. Like this there are n number of diagrams present, okay, which we will have to understand, and we have to make it very clear that every diagram what we are going through, it should be very completely clear to see that the forces which is drawn are understood clearly based on its nature, either it is a reaction or due to the weight, etc. Right? So like this there are a number of sketches. I can go for another one more sketch to show this. A body is like this. It's in a container. One more ball. It will be from this one. There are two balls here. The first one is as such. You can draw a proper sketch like this. The next one, this is having a support from the right hand side. Right? The right hand side of this vertical wall, as well as there is one more support from the other to the ball. Suppose this is body A, this body B. There will be reaction from the both the sides. This has to support that, and this to weight of this will be towards the body A. So I can take suppose the same sketch I am just adding. It will be in inclined direction like this. Is it not? From the force from B, it is FB towards A. I am writing force from ball B to body A. You can write FBA or F bar A, B bar A. And one more, it has to give reaction, is it not? Reaction towards upward. That I can take it as in the same direction. I will just draw it here. Instead of drawing it in the same line, you can draw it from the bottom. In this fashion, it will be more easier to differentiate. You can draw it this force in here also, but the nature is same. Either it is horizontal or vertical or it is inclined, nature is same. This I can write force from body A to B. So any body which is considered, we will have to just go through where are the supports, in which either it is due to self weight, the force is there, or from the left or right hand side, wherever it is. Like this there are n number of sketches given in the book. Those sketches we need to practice, and we need to understand the purpose of that forces. Then based on that the problems could be solved either by using your any laws of forces, parallelogram law or polygon law or whatever it is. Lamy's theorem, all this can be applicable as we did in the unit number 1. But this free body diagram is very, very important. Need number 2 to start with. We'll see 1 or 2 problems based on that, so you can better understand how do we solve a question, right?